Okay, hi guys. So this is the notes for the properties of special parallelograms. The special parallelograms are rhombuses, rectangles, and squares. Okay, so if we go down to our definitions here, a rhombus, I could get my screen moved as much as possible. Okay, a rhombus is defined as a parallelogram with four congruent sides, so all four sides are the same length. A rectangle is a parallelogram with four congruent angles, or four right angles. So 90, 90, 90, and 90. And then a square is defined as having both four congruent sides and four congruent angles. So it's got the four congruent sides and the four right angles. So a square is both a rectangle and a rhombus. All three of these are parallelograms because they all have two pairs of opposite sides that are parallel. So the properties still, for parallelograms, still stand. Right? So for all of these, we know that opposite sides are congruent. We know that opposite angles are congruent. We know that consecutive angles are supplementary. Consecutive and we know that diagonals bisect each other. Okay, so those four properties still exist. They still stand for all parallelograms, and rhombuses, rectangles, and squares are parallelograms because they have two opposite sides that are parallel. They just have the additional properties. Okay, so let's talk about each one. Let's start with the rhombus. So we define the rhombus as a parallelogram that has four pairs of sides that are congruent. We'll come back to that up there. Let's go down here though. Okay, so we defined a rhombus as a parallelogram with four pairs of congruent sides. So we have two additional properties then we want to use. One is that the diagonals are going to be perpendicular. So if we have a parallelogram that's a rhombus, then its diagonals are perpendicular. So we have four right angles. So we have 90, 90, 90, and 90. Diagonals are perpendicular. And then our other one is that the diagonals will bisect opposite angles. So we know that angle 1, 2, 5, and 6 are all going to be the same thing, same angle measure. And then 3, 4, 7, and 8 are also all going to have the same angle measure. Okay, so let's look at some examples. We're going to skip over the proof. Okay, and let's look at our example here. We want to find, let's see if we can't zoom in a little bit. Okay, we want to find the measure of all of these angles. Well, we know we can use the first one, that diagonals are perpendicular, to know that we're going to have right angles here, 90, 90, 90, and 90. It's not really good enough. Can I move? Yeah. Let's see if we can't zoom in some more. Okay. So we know diagonals are perpendicular, so we have 90, 90, and 90, right? All of these are going to be 90s, all perpendicular. Okay. We know that diagonals bisect the opposite angles, so we know this is going to be 58. There's the problem. I got to lower the pen size. So we know this is also going to be 58. Okay, we also know that 2 and 3 are also going to be 58. Right, alternate interior. So 58, 58, 58, and 58 for the rhombus. And then we got to find 4 here. So we have a triangle, and we know the three angles of a triangle add up to 180. So we know that 90 plus 58 is going to give us 148. Right? And then we can do 180 minus 148, which will give us 32. Okay. So the three angles of a triangle need to add up to 180. So we do 180 minus 90 minus 58, and that should give us 32. We would also know that this angle would be 32. This angle here is 32, and this one up here is 32. Right, so those are the two properties. You have 90-degree angles in the middle because the diagonals are perpendicular, and then the diagonals bisect the opposite angles. So you're only going to have two other angle measures there. 58, 58, 58, 58, and 32, 32, 32, and 32. Okay. What are the measures of the numbered angles here? So again, we know that these angles, all four of these are going to be the same thing. Okay. We know that these three angles all add up to 180. So it's a rhombus. So we basically know it's going to be an isosceles triangle. So to find those angles for the isosceles triangle, we did 180 minus 104, which is 76. Okay, so we know these two have to add up to 76 because it's a triangle. And we know they have to be equal. So all we're simply going to do is divide by 2. So 76 divided by 2 is going to give us 38. So all of these angles here are going to be 38. Right, those are 38 because that's what we solved for. And then since diagonals bisect the opposite angles, we know these are also going to be 38 and 38. So you have two properties for rhombuses. The diagonals are perpendicular, so you get right angles in the middle. And the diagonals bisect opposite angles. So 38 and 38. Okay, next up is rectangles. So you really only have one new theorem here for rectangles, and that is going to be that the diagonals are congruent. So we had the four original properties for parallelograms. Opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and diagonals bisect each other. For rhombuses, we added that diagonals were perpendicular and the diagonals bisected the opposite angles. And then for rectangles, the one property we're going to add is diagonals are congruent. Okay, so let's look at an example here. So they're giving us SF here is 2x plus 15, and RB is 5x minus 12. So those are the two diagonals of this rectangle. And since we know diagonals are congruent, we know their lengths are equal. So we can do 2x plus 15 equals 5x minus 12. Okay, subtract 2x from both sides. Add 12 to both sides. Right, those cancel, you're left with 27 equals 3x. Divide by 3, so x is going to equal 9, which is choice B. Diagonals are congruent, so you set their lengths equal to each other. All right, here they give you ln and mo. What are the lengths of the diagonals? So we need to find x first and then plug it back in. So for part A, it's a rectangle. So we know diagonals are congruent, so we can do 4x minus 17 equals 2x plus 13. Okay, subtract 2x from both sides. Add 17 to both sides. Okay, we get 2x equals 30. So you divide by 2 and you get x equals 15. Okay, we then need to plug that back in. So 4 times 15 minus 17. That's 60 minus 17 is going to be 43. Okay, and just to check, let's do the other one. 2 times 15 plus 13 is going to be 30 plus 13, which is also 43. So our diagonals are 43. Okay, B is asking what type of triangle PMN is. So that's this one here. Okay, and the idea here is that since both the diagonals are congruent, and the diagonals bisect each other, right? The diagonals are going to bisect each other because it is a parallelogram, and the diagonals are congruent because it's a rectangle. All four of these segments here are going to be congruent. So that's going to make this an isosceles triangle. All four, in a rectangle, all four of these pieces in the middle here are the same. Okay, only true if the parallelogram is a rectangle, because the diagonals are congruent and they bisect each other. Okay, and then for a square, you're simply adding those two sets of properties together. So a square is going to have the original four properties of a parallelogram. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Plus, you're going to add the properties for the rhombus. So there were two there. The diagonals were perpendicular, and the diagonals bisected the opposite angles. And then for the rectangle, the diagonals were congruent. So all seven of those properties will apply for the square. Okay, let's go up and then finish the one part we skipped over at the beginning here. So classifying. So again, rhombuses have four pairs of sides that are congruent. Rectangles have four right angles, and then squares have both four congruent sides and four right angles. So if we're looking at parallelogram ABCD, so it's terrible. ABCD, we have a right angle here. Since it's a parallelogram, we know since that's 90, the opposite angle is congruent, so that's also 90. And we know consecutive angles are supplementary, so 180 minus 90 is going to give us 90. So since we have one right angle, we're going to have, and it's a parallelogram, the others are also going to be 90, because opposite angles are congruent, consecutive angles are supplementary, and 180 minus 90 is 90. So that's going to be a rectangle because it has four right angles. So it's a rectangle. Okay, a rectangle. Four right angles. Okay, now they want to talk about parallelogram EFGH. So it's this one here. Okay. They have two hash marks here. It's telling us that these two segments are congruent. Since it's a parallelogram, we know opposite sides are congruent. So we know EF is congruent to HG, and we know that EH is congruent to FG. So since those two original ones were congruent and their opposite ones are also congruent, we have four congruent sides, which means we have a rhombus. So four congruent sides is a rhombus. Four right angles is a rectangle. If it had both four right angles and four congruent sides, it would be a square. Okay, and that's it for the notes. We'll do a screencast walking through the problems we have to do as well.